So I'm sharing my screen. So in last session, we have discussed about the demand planning, how to set up the demand planning, various master data we require, and how to upload the sales history, how to take a planning run in forecasting, and how we can create a planning view to see the whatever data we are uploading or whatever output of the statistical forecasting we wanted to see, how to take a run. So one thing which I wanted to add over here is the forecast error concept. So when I talk about forecast error, while creating forecasting profile, we saw that we can select various error measures to identify the best fit model. And, but let's say after that, like when this error calculation which we are using while using the performing the statistical forecasting, I wanted to perform this. So error, what is forecast error? That error is to measure the accuracy of our forecasting process, right? So apart from statistical forecasting, I wanted to see the accuracy of the consensus demand and any other demand input which is coming from other stakeholders as well, right? Because statistical forecasting is not the only output, only forecasting output will be used by the demand planning team. They will be changing, updating the output of the forecasting process, right? So every now and then, if I want to measure the accuracy of those other kind of forecasting or demand planning activities, so for that there is a different step that is called as forecast error. Okay, so let me open my system. So for that there is a different app for it, which is called as forecast error. So the same thing, this error profile which we'll be creating, it's planning area specific. So one forecast error profile which I have created over here. There is no any special thing we are going to add over here. The same thing for which key figure we wanted to compare and what kind of error we wanted to calculate. It's taking some time to load. So yeah, it's load. So here the same thing we can add for like what will be our historical key figure, what will be our forecasting key figure. So here I can, let's say last month we have released the demand plan after performing those statistical forecasting and consensus demand activity, planning activity. Then we wanted to see the accuracy of that, right? So last week, this same actual quantity or sales history or billing quantity key figure I can add over here, and I can add the forecasting which we have released. Okay, we can add the time scope as well for like the past, how many periods we wanted to compare, and what kind of, at which level we wanted to calculate the error, and what are the different errors. Okay, now so errors, in which key figure we wanted to see the error, that we can add. So let me show you this key figure in the key figure options. So you see there are, if I type error over here, there are certain error related key figures are there. So this forecast error key figure, this is a standard key figure which is there in IBP for every planning area, right? So here this forecast error.
When you said IBP is case sensitive, you put
Yeah.
small letters error. Why I am seeing all capital letters? It's nothing.
So let's focus on the session right now. We'll take your
Okay.
questions later on, right? Okay. Okay. So this key figure which we have created over here, at which level we wanted to calculate, we have created, and the same key figure we have assigned to this output activity. Okay. So one thing to note here is when we take this forecast, so when we are creating this error profile over here, this error profile, the output will only be in the current bucket. Okay, because when we are running it, we wanted to see the error. So the horizon which we have selected, it will consider that horizon. But after taking the forecast error run, we can see the output in the current time bucket only. There is no comparison between each and every time bucket, because the horizon which we are keeping, the whole horizon will be used for that error calculation. So after this error profile we have created, here this is the forecast error profile. We generally, this operator is there. So here this forecast error, that profile which we have created, we can use it to run it. Okay, I actually have already taken run, but let's take a run again, not an issue. So same thing, it will schedule a job and we can see the status. There is no difference over here in terms of the like taking a forecast error calculation run. So when we see the output, it will be only be in the current bucket only. Okay, it will not be each and every bucket, because the horizon we have already considered while considering the forecasting error calculation over here. So we can see each and every, for each and every product location combination, what was the error. Okay. So this forecast error calculation also generally used in IO. So in IO means in inventory optimization, we perform the safety stock calculation, and safety stock calculation also take forecast error as an input while calculating the required safety stock quantity. So there also we use that, but for measuring the accuracy, we can use this forecast error calculation as a separate profile. So demand planner can perform the accuracy check for the different activities they have done for the different product location combination or different kind of forecasting they have done. So for example, we are comparing the actual quantity and statistical forecast quantity. They can compare the consensus demand, which was the final output of their SNOP process. So that can also be used to identify any accuracies. Okay, so this was the concept I thought of introducing.
Yeah, Pawan, what is the value of one meaning? I am not understanding that one.
So this is the error. This is the error. So error which we have selected over here.
That is the error percentage?
Yes, yes. So error, this MAP. Okay, so currently it is showing in digits, So for this key figure, we can add formatting and we can convert it in percentage as well.
So can I say this is the 1% of error?
This is kind of a over 100%.
Okay. How will you calculate in the 1% means? I am not just to know.
So this is not 1%. I am saying this is like kind of a more than 100% forecasting error over there. The error accuracy is not good. So whatever they have forecasted, the sales quantity was actually maybe higher than that.
Just in explain, is possible to explain how this value is calculated?
So
here I am understanding, but
yeah, then we have to understand this mean absolute percentage error. Using this MAPE error, this calculation has been done.
is it possible to explain that one? Actually, I am new to APO.
Okay. So whenever we are saying about the error means we are checking these two key figures value. So this actual quantity means actual sales which has happened.
Okay.
And the statistical forecasting quantity, what was they have forecasted. For example, like when I am forecasting about January month, okay. So the forecasting process might have done in December, right? So in December month, they have forecasted in January how much we will be selling. Okay. So that will be your statistical forecast quantity. Now, when I'm in, let's say February or March, I know what I have actually sold in January month. Okay, so actual sales I have, what I have forecasted means what I have speculated in January month, that I have. Now I wanted to see the accuracy. Okay, so how can I see the accuracy? I'll take there are different measures to perform that accuracy calculation. Okay, so for that we have selected this MAPE method. Okay, so MAPE method means it will take a difference of all the like sales quantity and forecast quantity in each and every bucket, and so it will take a mean of it. Okay, and then it will calculate the error. Okay, so similarly we can convert it in a percentage also, because when we are taking just the difference, the negative positive value will cancel each other, right? So then we'll not be see at a consolidated level how the accuracy has been arrived, or the accuracy calculation will get disturbed, because the positive negative effect will cancel each other. So then we can use this mean percentage error or mean square error. So mean square error means whatever like difference we are calculating will convert into the square format. So when we are squaring the value, the negative positive effect will go away, right? So then we can calculate the forecasting error in a much better. So there are different ways to calculate it based on the like different kind of data you will be comparing.
So the X post forecast is already done, right? Would have been done. Otherwise, we would not.
Yeah, it would have been done, but whenever you run that forecasting process,
yeah,
right, this is to compare your like whatever has happened in the forecasting, or like apart from that, the consensus demand also, like after changing the values, what was actually sold, what was actually speculated, separately also we can calculate.
so
This
the
is
process
basically to
is,
optimize the future.
Yes, so they can improve their accuracy in future then using this process.
so the process is first the statistical forecast will run, and then do you have to run this error calculation, or it's part of that run?
It's not. It's a separate process.
Oh, it's a separate process.
It's a separate
In BPO,
process.
it's a single process.
Yes, it's a separate process. That is why this.
So once you have statistical forecast, so that means you want to compare what happened actually last month,
Yes.
whether you can trust it or not.
Yes, correct. So statistical forecasting is not the only output they will use it for to speculate, right? That is just an indication for them based on the historical data. But they might have updated with respect to like getting the information from their dealers, from their customers, from higher management also. They will get some input, right? So that all the experience will get into it and it will get updated. Okay. So that will be a final approach towards your demand planning, right? But you have to measure the accuracy as well, right? So how much you have speculated and against how much you have actually sold. Okay. So when we are performing statistical forecasting, that will do anyway, but it will be a statistical forecasting only. But when I want to compare the actual sales happened and whatever we have speculated, for that this forecast error, a separate process is there.
One thing here, there are two speculation. One is by the system, one is by the individual.
Correct.
So we are right now doing the individual forecast accuracy, yeah,
Correct.
not the system forecast
Not
accuracy.
the system. Yeah. Yes.
So the statistical run, whatever it calculates, the forecast error will be automatically calculated when the statistical.
Yeah. So we can. Yes. Correct. That will be automatically calculated and internally used to perform the statistical.
Yeah. So that's same as API. It's not separate process, but this is only to evaluate individuals' performance.
Correct. Correct. Okay. And using this, they can like improve their accuracy for future purpose also.
Yeah, I got it.
So that's why there's a separate operator over here to run it.
So in this example, you ran only for 1 week, or?
So this is no. So when we are creating this profile, we are giving the horizon for which horizon we wanted to run it.
So only 1 week is showing an error.
So here the output will be shown in current bucket. This is 11th week we are running as of now. March.
Okay.
So here, how can I tell
the question
current week
is where we define this one period only, or is it a default setting?
It's a default setting. The output of the forecast error will be in current bucket.
So, but that is comparing last week or which week?
It is comparing the periods, which periods which we have defined in the profile.
So let's say you are doing comparison for 1 year, but you are giving only for current period.
No. Just understand one thing. When I'm calculating the accuracy, I am calculating the accuracy for whole horizon.
Oh, okay. So for all 52 weeks together.
All 52 weeks together, and it is giving me the accuracy output in this current bucket.
So we cannot compare like each week, like.
Yes, so that's what I'm saying. It is not comparing each. It is comparing each week, but it is calculating the consolidated error for you.
So I cannot see like every week.
Yeah, so every week will not help you in taking decision how accuracy, how good.
Okay.
Right.
There is some forecast accuracy formula is there. So if you go to the MSc or MAP, that is statistical forecast error calculation. On that, it will look at all the periods and it will give you one number only, and it will tell you that is what is the percentage of accuracy or what is the percentage of error. That is what is it's taking the 52 period for the past.
Right now we do like every month, so that's where I'm trying to see.
I think you are saying this one, forecast accuracy. This one you are saying.
Oh, you're asking me?
No, someone was saying about this. One more option of
forecast error. I believe forecast error is calculating for the let's say you have mentioned 52 periods, then it's taking the 52 periods and it's calculating the at a single number as the what is the percentage of the forecast error.
Correct.
It's similar to the APO only.
Yes, similar to the APO. So that's what I'm saying. The output will be in the current bucket only. When we wanted to see the output. So the difference over here is in statistical forecasting, whatever error we have seen, as we discussed in last session also, we have to go to logs to see the error. What was the error, right? Every now and then. So here we can add it in this key figures as well, and we can compare different kind of whatever forecasting we have done, right? So we can compare our actual sales with the statistical forecasting, also the final demand which was arrived after updating with the different inputs from different process, like different demand planning teams or sales senior management team. So that output is there. We wanted to see the accuracy, how accurate was the planning process, demand planning process. So this error will help us.
So here.
So this error will give us the indication of the accuracy.
So here, if you talk in terms of demand, let's say like for the total year, you say like 1,000 demand. So if I say 1.05 error, so is that like my forecasted demand is more, or is that like actual quantity is more?
So, sorry, can you come again?
So you are saying 1.05 is error, right? So is that like forecasted demand is more, or the actual quantity is more? I mean, which one is more? I mean, we know it's error, but so is the actual quantity is more than what we forecasted, or?
Its actual quantity is more than that. So I'm just assuming when it is showing like more than 100%, or then it will be like the actual quantity is more for me.
Okay.
Okay. So this is the thing which we can generally use to calculate your forecast accuracy. Now, apart from that,
one second. When you said 52 weeks in the past, can you go up? And also, there's 52 weeks in the future.
Yeah. So that.
Yeah. So are we looking at the 52 weeks of past and comparing 52 weeks in the future? Huh?
Yeah. So the scope is also there in terms of comparing the past and like future speculation as well. That is also, the scope is there.
But actually, it is comparing in the same past, right? Actuals versus what you have forecast in the past.
Correct.
But this second line 52 in future is not clear.
So does it mean like it's saying that for next 52 weeks, this error will be constant if you follow the same process?
No. It's not like that. So it's like the time scope means like for how much horizon we wanted to compare the data.
I understand that it's only showing in the current bucket. Say showing one in current bucket. That implies to the future forecasting. If we don't change anything, this error will be constant. So suppose for March, April, if we follow on the same thing,
it's not speculating the error for your future horizon.
Okay, only comparing the past.
It's just comparing the values. Okay.
So what's the significance of putting this future horizon?
I think maybe if you are using lags, then maybe this future period will help you.
Okay.
Okay. So that is why this.
Can you try a different number and see what happens if the value changes, like on the future, not on the past?
Then we have to put some data, right? I haven't put any data in future as of now.
Oh, actual quantities you are talking?
Yes.
Oh, then generally we don't have a future quantity, right?
Yes,
actual quantity.
Yes, correct. So this option is there. I'm saying this option is there to compare the future data as well. Okay, I'm not saying that this key figure will have the values for the future as
well.
Okay. So forecast error we have discussed.
For future, that is my assumption. For future horizon, I think probably you may have statistical forecast, and also there is some demand change, right? All demand drivers will come and pitch in and they give positive or negative values. Based on that, you'll have some numbers, I think. It's not about actual values. That's my guess.
Correct. Yes. So that's what, correct. So that's what I'm saying. So when we wanted to compare different key figures and checking the accuracy. So for that, what kind of data we wanted to compare? Future, past, only past or only future? That option is there to calculate those errors. Okay. So moving forward, like this ABC XYZ classification. Now the profile we have seen earlier as well, but let me tell you the one concept of ABC and XYZ. Let me open this. So say the same thing, whatever setting we do for ABC, XYZ also, it is at the planning area level only. Okay. So with this same profile, we can run ABC and XYZ at the same time, but we can select an individual segmentation as well based on this on and off, in which attribute we wanted to save this output of this ABC classification. That will be done in this attribute only. Okay, what was the key figure we wanted to compare? For example, this revenue, we can compare the quantity as well, and at which level. For we are comparing at only the product ID level, and what will be the periodicity while considering the data, and what will be your this horizon to consider the data of this key figure. Okay, now here there are certain principles to classify it. Okay, so when we are saying classify these products, like which we wanted to run this ABC classification, there are certain principles to it. Okay, so the first principle which we have selected is this Pareto principle. So when we say in this Pareto principle, let me just give you an example of Pareto principle over here. So how Pareto principle work is, like whatever, let's say we have 4 to 5 products for which I wanted to classify them. So these are the sales. Just consider the same thing, sales revenue. So the revenue which is there, what this Pareto principle does is it will identify based on the segmentation or classification we have created over here. Okay, so A classification will be given to top products which are contributing 70% revenue. Then the remaining, the other 20% contribution products will be given the B classification. Then the remaining will be given the C classification. How it will do is, it will first of all sort the products based on their sales revenue from high to low. Okay, and it will calculate the percentage with respect to the total contribution of the product sales. Okay, so here we have identified. How we have done is, I have arranged in the higher to lowest value and calculate the cumulative value of all the product sales in a different column, and then the percentage of it. So that this was the total sales for all these products, and out of that, how much is the contribution of this particular product. Similarly for all the products. Okay, so whatever product are falling into 70%, they will be given a A flag, then B, and then C. This is how this Pareto principle of percentage will work to identify the ABC classification. Similarly, we can give values as well. Similarly, if we don't want it to follow this Pareto principle, we can give our numbers in terms of percentage and values as well. For example, if I select this value, we can give, okay, above 10,000 revenue should be given A, from 5,000 to 10,000 should be, and below 5,000 should be given C. So that kind of classification also we can add over here. Okay. Similarly, for XYZ also, the segmentation in which attribute I wanted to save the output, what will be the base or data this segmentation process will consider. So this is the key figure we have identified. Which level I wanted to see the classification. Generally we focus on at the product level only, and the periodicity of the data and the horizon. How much or how far the horizon the data should be considered, and the variation over here. So this variation will help us to identify, okay, how the fluctuation is in the sales quantity data is there. And here we can give the different segmentation for what kind of variation we have. So whenever, so here we generally, any business will like those products, will want to target those products where the variation is low, right? So higher the value of this coefficient of variation, higher is the variability in your this sales quantity. Okay, so we are giving the X to those products whose this coefficient of variation, which is the fluctuation, is lowest from 0 to 0.3. If it is above 0.3, it will be given Y. If it is above 1, it will be given Z.
Do you have different options instead of 0.3 or something else?
So you can put your values also.
No, I know. But like XY, ABC, we have different option, either pieces or percentage.
Okay, so here we have two things. Here we have two methods over here.
Yes.
Generally,
and how often you run this?
It's a I think it's a quarterly or half yearly activity.
Okay.
Every now and then you will not classify your product, because based on this classification, your all those demand planning process, your stocking policy, everything will change, right? So that policy is generally kept for 3 or 6 months. It will keep a constant policy, right? You will not be changing those policies every now and then or every month.
So you can run this in the background and forget about it, right? Yes. It will run automatically.
Yes. Yeah, you can schedule it, and rather than scheduling it, I will recommend it that you should be running it manually.
Oh, manually, why?
Manually, why? Then you will know, okay, this was the output, and then now it got updated. Now I'll show you where, like, we can see the output of this ABC classification. There is no change history. Okay, initially it was like that. Right now it is like that. Okay. So when we want to run this ABC classification through application jobs, we can run it. So initially this ABC operator was there. Now I think they have discontinued and given as this ABC segmentation. So here we can give for which planning area we wanted to run it, for which version, the data, the segmentation profile which we have created, and any filter for any like product location, anything. Right now I'm running it for each and every product. So you'll see when this log is created, here this segmentation will show us what step it has done. The same thing, the spool which we used to see. So this segmentation is completed. Now I'll show you where we can see the output. So we have created this, while creating this profile, we have selected at which level the output should be. So it was at the product level, and there we have two attributes, ABC and XYZ. So here for ABC, in this ABC code, we can see the output. Similarly for XYZ, the attribute will be here. Okay. So we can see this thing, I think here as well, in planning view as well. There's a ABC. No, it is not. So we can create an attribute as a key figure as well, and we can show the output for this ABC classification in the planning view as well. But generally we run it and save it in the, like, just like in APO also, there's a ABC indicator. So like this ABC classification can be stored in this attribute of product master data. So generally, like after 3 or 6 months when you run it, then on the basis of that, you will identify, okay, or you will have a discussion, what kind of forecasting process should be there. For example, the same thing which we have discussed. If the product is falling into A category and the demand and it is subsequently it is also falling into X category, that means the volume is high. Also, the forecast or the demand for that product is also not that much fluctuation, right? So based on that, the forecasting process will be different. Similarly, if the volume is low, but also the variation is low, for that you will have different kind of ordering. For example, cross-turn model in terms of the forecasting process, but also you may wanted to go to not to made to stock policy, you want to go to made to order. Whenever you receive that order, then only you will process it. That kind of decision also we can take using this ABC and XYZ classification.
Can you go back to ABC screen once quickly?
ABC, the profile which we have created?
Yeah. Yeah, can you go down? There is filter value. I saw. I think not this screen. There is another screen.
While taking that run.
Even while running the job, there was a filter option.
Yeah, there was a filter option, so we can filter. We can put the filter for which product.
I was thinking, can we attach a variant to this?
Variant concept.
I saw some ID kind of thing.
Yeah, so this ID was assigned to that filter.
So
that ID was assigned to that filter.
Profile ID.
So this segmentation profile ID means whatever segmentation profile we have created.
So that's our variant, similar
no,
to
it's
variant?
not. It's not a variant. The profile. So you can see there are 3 to 4. Let me open up. So in this planning area, we have 4 different profiles are created. Okay. So based on the planning area, we are selecting.
These profiles those are 4 variants, right?
Yes. So no, it's
okay.
Yeah. So it's not a variant. The variant concept was totally different because we can put lot of things there for different settings related to whatever fields were there in that screen. But here, this is just a ID assigned to that particular profile. That variant concept was I haven't seen here till now. Even we are waiting for that.
So this is a planning area. Okay.
Yeah. So when we select this planning area, whatever profile we have created in this planning area, that will show you. So that we can select which profile I wanted to run.
So these 4, I believe they are different variants. So why we create four profiles under one planning area?
This is a test system. We can create it.
Correct. Okay.
So there's
but
no.
Same way I can create 3-4 profiles for 3-4 markets separately, right?
Yes.
So it's nothing but a variant.
Okay, you can, if you want to consider as a variant, this is variant.
No, I'm just trying to compare APO and ABP.
So I'll request you don't compare. Then you will be confused. Lot of things have changed. You will be confused. I'm telling you. Take it as a new concept. If it is something similar to that, then I'll tell you. If it is not, then it's not, because variant thing was very strong and very useful. But here we are waiting for that, because whenever we take a run, we have to put all those settings every now and then. You have seen that, right? Whenever we are taking forecasting, I have to select all the values every now and then. The variant will help us there while taking a run.
So that concept is not here.
Not here, yeah. Even we are waiting for that. Because you will see while taking supplier, and every time I have to select the profile, every time I have to select the IDs and whatever planning I wanted to take. That's a pain right now. Okay. So yeah, so ABC and XYZ we have seen. It's a like looks like a simple process, but very useful for business, because based on this they generally have the further discussion whenever like 3 months or 6 months they have those future policy discussions. Now this thing, which new product introduction, which someone was saying, like modeling and the phase in phase out. So same different terminologies are there. So here in IBP it is the concept is introduced as a new product introduction. So for this new product introduction, they have introduced a separate app for it, which is called as Managed Lifecycle. Managed Product Lifecycle. So when we come over here, what we can do is we can create a reference or like modeling concept over here. For example, if any new product which has been introduced, for example, this new product which I have added over here. So when we add any new product, for that product, what will be your reference product? Let's say if you wanted to put more reference, for example, if the new product which has been introduced, it will have characteristics of more than one product, then that way we can add more than one reference product as well. Okay, but we have to give the weightage. Okay, and the weightage logically should be 100%. It can't be more than 100%. And after adding the reference product over here, we have to select what will be the key figure which will be used to perform the statistical forecasting. Okay, so when I'm saying the new product will not be having any sales history, right? So to perform the forecasting of a new product, we'll need some reference, right? Okay, and that reference will define over here. And when we are giving the reference of the product, what data we should consider of this reference product, that we can select from this key figure option. So we have all those key figures available here. We'll select the relevant one, which is the actual quantity where we are storing our sales history, and what was the horizon for this key figure data should be considered. That also we can add. Okay, now apart from that, we can also add the phase in and phase out of the reference product over here. Okay, so let me add one phase in. Okay, so we are adding, so there are different dimensions over here. For which dimension I wanted to add this phase in. So dimension means, for example, for certain customer, this product may be replaced, right? Or for if replaced means the same thing, the phase in of a new product and phase out of a old product or reference product. Okay, so for one customer, I'll create this phase in phase out dates. So phase in start means for this new product, when it is the sales of that new product is going to start. So I'll just give it from today. And phase out means when this phase out of that product, new reference product, is going to start. So I'll give same date. Now phase in end means, so when we are telling the system like which product or which reference product sales history should be considered. Okay, so there should be some horizon, right? After this, for example, if I have started selling a new product from March, okay, I will not be having the sales history of that product for February and January, right? But after that March sales has happened for that new product, I'll be having a sales history of that new product as well, right? In April, right? While performing this planning in April, I can have some reference of March sales for that new product, right? So The phase in end date means up till which end date we wanted to consider the sales history of our reference product. Okay, so for example, here the same example, if I consider the new product which I have introduced in March month, I wanted to consider the sales history of reference product till March only. Then after that, I will be having my own sales history. So that way we can use this phase in end date. Okay. So I'll give some weeks, some 3 to 4 weeks, and phase out end date. So phase out end date means after this date, there should not be any forecasting happening of this reference product, right? So after this date, the product we are not planning to sell this product. Okay, so we'll not be planning any forecasting for this product in my future. Okay, so same date I will select. After this 6th April, the forecasting should not be there for this customer.
So one second. So here you are saying that one product is a predecessor and another is a successor.
Yeah.
So when you are introducing a successor, that you are saying phase in is that, and for the predecessor, the right side dates are the.
Yes. The phase out date is for reference product and phase in date is for your new product.
Okay, if you don't have a predecessor, a brand new product.
Yeah.
So then you don't fill the right side values.
Yes, correct.
Pawan, what is that phase in curve and the phase out curve?
Yeah, so we like whatever dates we have put, this phase in curve we can create over here based on the date. So there's a simulate option over here. So let me.
But here we are not assigned a product yet, right? For which product is this?
So the same setting, the same profile we are using. So this reference product we have already defined over here.
Okay.
So this is for this reference product only. We can use the simulate to just create a curve for that. So some periods. So it will just give you how that phase in and phase out is going to happen. So we can create phase in and phase out different curve over here based on these like different periods.
Okay. Yeah, okay, and so those can be assigned.
It's just a simulation.
Yeah.
The good simulation part, which I like it. Let me save it. This simulate option over here for the data. Okay. So here for this key figure, we can see reference product actual data, actual history over here. That also gave us, okay, this is the sales history of reference product, which we are going to use for this new product. Okay, so we can see in a graphical manner as well as in the table format for this product.
So what is the new product name here?
This is the new product. This is the new product.
Oh, that U under AX is the product name. Okay.
Yes. This is product name. Okay, we can see outside as well. This is the new product. Okay, this is the reference product. 100% weightage. Okay. Now one more thing. So when we are creating this phase in, phase out, we can generate the phase out as well. What happened? We have already added it. Haven't we saved it? Okay. So we can generate the phase out of reference product from here. That will show us, okay, for this product. So whatever value here added over here, that date will be considered to generate the phase out of that reference product. And then
Okay.
Let me check it again. It should be there. There's some issue with this, huh? Why it is not saving?
What is that? Settings profile? No settings profile is assigned on the top left.
No settings profile. I think here. If there is any settings we wanted to assign to it, that we can do. I haven't used it actually, like this settings thing, but it's
like in API we do suppose product, customer, or DC level. Like then we do basic settings.
Yeah.
Is it similar to that?
No, it's not like that. So for that, like you will be adding that, like for which level you wanted to perform that phase in, phase out. That's what you're saying. So that we are already doing over here. Okay, use a phase out date. Phase out. Okay, it is showing some issue with this. That is why it is not saying. Use a phase out start date. That is after the phase in acted for new X. Okay.
You cannot have a phase or date before it starts.
Okay. So let me give a different date. That is after the phase in ended. Okay. So it is telling me after this phase in ended. Okay, no, not like this. So what I'll do is I'll shift this date.
Yeah, 4/6/2019 is phase in end. Yeah. So beyond that, 4/7 you can take. Yeah.
So this is May. So this one. Okay. Okay. Now it has saved. Let me verify this thing again. No, so now it is there. Okay. So after adding this new product settings over like reference product and this phase in, phase out, to consider these settings in our forecasting profile, there is one checkbox we have to select. Let me open it in a different tab.
There is a small checkbox in the statistical forecasting.
Yes, correct. So that we have to check, otherwise this settings which we have done over here, that will not be considered. So in the forecasting steps, we have to use this consider product life cycle information. Then only the settings which we have done over in this manage product life cycle, that will be considered. Otherwise, it will not consider. Okay. So after performing this new product life cycle related setting, then we can take a run.
Is there any concept here like you schedule versus release?
Release, schedule versus release means I didn't get you.
So suppose schedule means, okay, I'm scheduling a job to run tonight at 10 o'clock. Huh? But if I don't release, that will remain in schedule like that in APO.
Okay, like this, like it was there in SM37 while scheduling a job.
Yeah, simple. Yeah.
Okay. No, here, no, it's not like that. When we schedule it, we schedule it.
It will run automatically. Huh?
Yes.
So we cannot control it. Okay.
Yeah. So after taking this, I've already created a view over here. Let me refresh it. Okay. So what it is doing is, it is calculating. There is no sales history for this new product. Okay. Now here, for this customer AA and the customer BB, there is no sales for quantity for this new product, and the forecasting is happening based on the sales history of this product. Okay. We have given some phase out start date, phase out date for this customer as well. So the statistical forecasting is not happening after that period over here, and which will be overlapped by this new product for this customer A. Okay. Why it is not happening after that? Because some sales history should be there. Then it will consider for the future forecasting as well. So like this, like we can give that, perform that like modeling and phase in, phase out in a same profile over here. Now let's say I wanted to manage it, so I can deactivate that profile as well. That also we can do, rather than deleting it. Otherwise, like we'll have some history for which the profile we have created for like this new product which was introduced.
Can you download all these entries?
Yes. So this, using this one, export to spreadsheet.
Okay.
Just select it. So this, everywhere this option will be there. I think most of the list will have this option. Not over here, but somewhere we'll be having. Generally, like in response, it helps us. We generally download all the data of the planning from this in Excel to perform the further analysis. That I'll show you while discussing the response. Okay, so here I wanted to show you one more thing at the help as well. This difference between error measure calculation, which we are discussing, while discussing the forecast error. So in the SAP help also, this is the SAP help page for this forecast error calculation. Here it is saying error measures calculated during forecasting. What is the business purpose? To test the algorithm that are used for forecasting and make sure that the best ones are used. Okay. And the error calculated in this managed forecast calculation error, to monitor the accuracy of your actual forecast and validate whether the different sources of input add business value to the forecast. Okay, so that is why like this a separate app is created to calculate your forecast error. Okay. So we have discussed. Okay. So we have discussed these three concepts. Now some introduction with respect to the demand sensing. So let me give you an overview. So we have discussed the demand sensing concept, but with respect to that algorithm for demand sensing, there are some prerequisites we require. Okay. So these are the some settings we have to do. First of all, the master data, which generally it is uses the same thing, product, location, customer. But the main thing we have to notice over is that period types. Okay. So the demand sensing will require days and weeks. We can't do it at a month or quarter level because it's a short-term forecasting. So the algorithm will work only if your this period types and days and weeks while performing the demand forecast sensing. Similarly, the planning levels, like since the days or weeks are there, so the planning level will be only at the weeks or days level. Okay. And so I told you it will consider the demand planning as an input as well. For example, we have done demand planning for as a monthly activity for future months, right? April, May, June, right? That it will also take as an input. Okay, so as an input it will take, but at the weekly bucket. Okay, so that is why this consensus demand should be at the weekly bucket. Now the output of demand sensing will be at the day bucket. Okay, so we should be having a key figure to save the result of demand sensing at this product, location, customer, days level. Okay, now but the other thing is we have seen that while performing the demand for statistical forecasting, there was a option in which version we wanted to take that run, statistical forecasting, right? But using demand sensing, right now SAP has allowed to take this demand sensing run only in the active version, which is called as baseline version. Okay, so this version baseline the same, it's a like in APO it was like 000, but here it is called as baseline version. Apart from that, in your statistical forecasting, in pre-processing steps, there were three options, right? Like removing the missing values or outlier correction or promotion sales lift elimination, right? So in demand sensing, we can only add this promotion sales lift elimination from the sales history. Okay, we can't the options of substituting the missing values or outlier correction is not there for demand sensing. There are some restrictions with respect to the algorithm for this demand sensing. Okay, the same thing which we have discussed, it cannot contain any pre-processing apart from this promotion sales lift. They can only contain one forecasting step. Right. So just opposite to the statistical forecasting, where we can add all those different algorithms, single exponential or multi-regression or simple moving average, right? We can add all those different multiple forecasting algorithms. But while using demand sensing, we can only add one forecasting step. Okay, there are no calculation allowed, or they're allowed for the demand sensing. Okay, and why? Because we are not calculating any ex post forecast. If we have the ex post forecast, we can have these error measures as well. Okay, same thing. The output will be the lowest level of the output will be created at the low, like day level, that will be the lowest level where we can have the output of demand sensing. Okay. So since it is giving the output at the day level, it is taking the input which are called as demand signals. So whatever demand signals we have, we are taking at the input only at the day and week level. That is why the consensus demand should be in the weekly bucket, because daily bucket it will not make sense, because the demand planning we generally do at minimum generally at the week level or month level. Okay. So whenever we are forecasting, whenever we are running, we can run it through two ways, right? One is the application job, the other is the forecast Excel UI, where the statistical forecasting option is there. So whenever we are running through Excel UI, your planning view should contain this customer location product planning levels in your planning view. Okay. The same thing which we have discussed, the output will only be at the, or the run of demand sensing will only be at the baseline version only. Okay, let me show you the profile of demand sensing. So here, when we are creating a demand sensing profile, the periodicity should be at the day or week level. The same thing, the historical periods or forecast periods, for which period we wanted to perform it. Okay. In pre-processing steps, when I am trying to add, the other pre-processing are disabled. When I'm going to forecasting steps, here this plus option is disabled as well. Okay, so what kind of different parameters it will take? The same thing which we are performing for the statistical forecasting. It will take the input from the requested quantity. So these are the different key figures where you'll have different values. For example, this requested quantity can be your sales orders, which will take it as an input. The output will be your sales demand quantity. This is the standard key figure to give the output of demand sensing. Here, there are certain other inputs it generally take. The consensus forecast, where we have performed the your final demand planning. Okay. Now there are other key figures as well. The snapshot key figures. So whenever we are keep on running, so this demand sensing, it's a kind of a weekly or a like bi-weekly activity, right? So whenever we are keep on running, we may wanted to create a snapshot or create a copy of your earlier output as well. So there it will perform the copy of your previous sense demand in this demand planning quantity snapshot. So these settings are there. While running this demand sensing, I'll explain you how this bias horizon help. There are certain other inputs we can give, like how much forecast increase or decrease in terms of the quantity or percentage we may allow this demand sensing to give us the output. So whenever it is taking the different demand signals, at which horizon we wanted to give it. Okay. We may want to add some other signal as well. For example, the POS data is there, right? So that also we can add using this add option, whatever key figure is there, where the data is stored.
So when it does copy will be available in the Excel UI as saved, the copy demands copy of snapshot, you know?
Yes. So this key figure, so this snapshot is a key figure. So here, okay, it will be a snapshot over there, and we can, while creating a planning view, you can add this key figure over there. So it will show you, okay, this was the snapshot which was created.
Okay.
So that, and also since it is giving the output at the daily level, we can select the work days as well. Okay, at which days we wanted to have the output. Okay, so that also we can configure from here. Similarly, if I go to any error measures we wanted to select, so here all the error measures are not allowed because there is no ex post forecast we are calculated, which is disabled in this demand sensing. Okay, so any questions with respect to demand sensing?
So this is not part of the statistical, but it's a separate run, right?
This is a separate run. This is a separate run. So it's a new feature which they have introduced. Till now, we haven't seen any customer to try it out because it's still that it is the IBP is still in adoption phase where people or client is still adopting that traditional statistical forecasting. They are still evaluating that product, but we have given some demos to some clients, but yet to see any adoption of this demand sensing output, because this is where we are telling the client or any demand planner that will be your next week demand. You can go ahead and execute it, right? So to achieve those flexibility in your planning process, your supply chain team should support you, right? Whenever you release the output based on this demand sensing, they should be able to like execute it, or first of all accept it, whatever this output we are giving them. So that verification is still pending.
I have a question. It looks like it runs in very shorter horizon.
Yeah.
The demand sensing output might have an impact on the deployment confirmed requisitions.
Yes.
Is it true?
Yes. That's what I'm saying. So that is why
first 4 to 6 weeks will be your deployment horizon.
Correct. So that's what I'm saying. Whenever this demand sensing is giving you that such a short-term output over here, it is suggesting the deployment as well as what you should manufacture, right? And which is generally kind of an execution which you are suggesting, right? So execution via demand planning is a very nobody just go ahead and execute based on the demand they have released, right? There are generally other factors to it. The material is available or not, right? And the capacity is available or not, right? So that kind of capability
then the demand planner should collaborate with supply planners and the materials.
Yes. Correct. Okay. So the supply plan, so that's what I'm saying. Your supply chain should be that much agile or that much flexible to accept this demand sensing output, right? So demand planning is also getting into the execution part from over here.
Yeah.
So here it's kind of a much more sensitive topic to talk about when we are talking to any demand planner, because they just release their demand plan and leave up to the supply chain team to perform the production activities, right? Or any logistic team to perform deployment.
So this is kind of executing on the overlapping horizons.
Yes.
In which case, much more collaboration is required.
Correct. Much more collaboration, much more capability to accept those different numbers, right? So because this is just a calculated number, and we don't have that visibility of how different parameters it has considered. We can perform those settings over here. Okay, how to consider, like what horizons that data should be considered, but that backend logic, because in statistical forecasting you have the scientific methodology is there, which we can any demand planner will know, right? This exponential smoothing or any multi-regression they will know, right? But this demand sensing is a very new concept because it is based on the different demand signals. For example, the recent sales order or your POS data. Based on that, it will use them for your pattern recognition. Okay, the pattern recognition it will see and it will suggest you something. But the overall logic is not in your hand. You can just suggest or say, okay, based on the recent sales order, it has suggested this demand sensing. Okay, so that is why like it's kind of a much more it will take some time from the client perspective to accept it, because demand planning itself from the like APO or this IBP perspective, they take certain time to adapt it, right? Whatever output is there, they should be able to understand it first and like accept the output. Like it's up to
but this forecast will be in line with the earlier statistical forecast which was released, isn't it? So
it should be in line with that. So that is why it is taking this input of your demand planning as well.
Yeah.
Right. So it is considering your statistical forecasting output as well. It is doing that, but apart from that, it is also considering the recent sales history. So it in theoretical terms, it sounds good to inform client, okay, you can consider a recent sales history as well, but we know how sales orders are created in the system, right? Generally, they are in certain time or certain client, it may be real, but at some places it is based on the target sales they wanted to achieve, right? So your data also will require certain discipline. Also, when we are saying POS data, or your POS data should be that much clean. If your that data is not clean, it will show you a garbage value, which will be able to validate it and like support it.
Yeah, thank you.
So this option is there, but still like even we are evaluating, and we are like whenever we give the demo, this settings or this information we shown to them. I'll show you like I still have to configure this demand sensing, but I'll show you how it will affect your the forecast which like consensus forecast have or statistical forecast have suggested, and how after the sales order consideration, how it is giving you sales demand. So that I'll show you, but right now I don't have, but in the next session I'll surely show you the effect of it. Yeah, any other question or point?
Yeah, Pawan, in below in demand sensing full, there is something called as delivered quantity, right? Delivered quantity adjustment key figure. Why that is required?
So this is ordered quantity and how much you have delivered, like how much. So it is not just only considering your sales order, the delivery quantity also it is considering. Your that capability to see, okay, how much quantity you are actually delivering. It's not just considering your sales orders only.
Yeah, the ordered quantity is basically ordered quantity. Delivered quantity is from your deliveries, outbound deliveries.
Outbound deliveries, yes.
Invoices.
Yes.
Yeah, not invoices, outbound delivery quantity.
Like but whatever, we won't get 10 types of inputs into APO. We get only either history, sales history, whether we fulfill or not.
Mm-hmm.
So it looks we are having different types of inputs.
Yes, yes.
Yeah.
So if I have only one, then which one I have to take?
This is based on real-time data. It's not history.
It's
this is basically
real-time also history. Real-time means yesterday something happened. That's a history.
No, it's not necessarily history. It is live data basically. Live data from ECC or S/4HANA.
Correct.
Are we working on live data here, or last 2 weeks of data are processing that?
No, but when it comes to demand sensing, it is live data.
It is live data, yes.
No. These are like basically your SNP key figures rather than DP key figures.
Correct. And like generally we keep the horizons not that much large, otherwise your data will be that much diluted. So we generally keep as focused as possible. Otherwise, we increase the horizon. The output of demand sensing will be, that accuracy may get down. That is why it is in terms of the weeks.
So it's not at all looking at history. It is only from week 0 and future.
Yes. We are not going to the sales history. Demand sensing.
We are not going even into yesterday's data. It's only today's data.
Yes.
So for the demand sensing, the input will be the transaction demand also. So for that one, we need to download the template and then we need to fill the data and then you need to upload, or how it will be?
Which data you are saying?
Demand planning quantity key figure values.
Yeah, so these key figures will be considered. We are specifying which key figure to consider.
So first you are running the demand planning.
You don't have to upload anywhere. The data will be already will be there in this key figure. Okay, so for example, when I'm saying this delivered quantity, I'm not uploading anywhere. It should be there. So we have to configure our IBP to get these data from your ECC. So when I'm talking about other downstream signals, for example, POS data, then your POS data should be configured with your IBP. So it can be in terms of upload also, but that one more activity will get added before performing this demand sensing.
Okay, if I have order quantity of 200 pieces and I already have delivered 100 pieces and the left out is only 100, where the demand planning quantity, that is through demand drivers, which has put 250. So I'll be considering the realistic data saying that, okay, it's only 100 pieces left out, something like that, right?
Correct, something like that, correct.
So Pawan, basically, where can we see the output of this algorithm?
This is the output.
That's what question. Okay, sense demand. Okay.
Sense demand quantity. Okay, so I have some planning views, but I have to refine it to show you in a proper manner based on these key figures. So that I'll prepare it first and then I'll show you, rather than doing it right away.
Yeah, okay, that would be good. Yeah.
Okay. So then you will be able to get it how that like where we can see the output, what are the different key figures we have considered, and how that output is improving your accuracy level.
Yeah.
Because you can't just use the demand planning at daily level, right? At monthly level, maybe 100. When you are disaggregating it, you will not disaggregate equally, right? You will require some signals. So that is where the recent sales order help you. That the demand pattern. Okay. So that demand pattern we'll see, and I'll see the output as well.
Hey, you configure like something like 294 days in the past, right? So then where are you using that? I mean, because you're saying like we'll only consider the current days, right? So what is the importance of this one? 294, whatever.
So this is your or historical periods for horizon, but here this for each and every key figure you can specify the horizon as well. That was for the overall your demand sensing. Okay, but here we are specifying like, so this demand planning quantity will be considering this historical period, right? But your other signals you will have this horizon as well.
Yeah, I mean, let me explain. I think that this first of all, this demand sensing is a pattern recognition algorithm given by SAP. I think which can compare your history pattern as well while calculating this output. That's why you can give sales history horizon of 1 year or 2 years, whatever it may be, but it will also focus on what is the current sales order pattern and deliveries pattern to come up with the final output. So it is kind of it's not statistical methods. It's a different algorithm altogether. Pattern recognition algorithm they call it as.
Correct.
It can compare past history as well as current sales order trend and your delivery trend.
Okay. Now I think it makes it a little clear, I guess. Yeah, thank you. Yeah, because that's why I was confused. Like you're saying, like we're considering 294 days, but when you said like we're considering only 1 day.
Yeah, so because it is a pattern recognition algorithm.
Okay, cool.
Okay. So in next session, I'll discuss about the demand sensing first, and then we'll move on to the supply module. Okay. So I think I'll be traveling next week. So I think on Saturday we'll not be having this session. On Sunday we'll have our next session. Just wanted to inform you on prior.
Okay. So you said like we also have the realment you will be covering, right? So that you will be covering in the next session, or
that I have to configure it first, then I'll show you. Since I'm traveling this week, so I'll not be getting this time, but I'll definitely show you that realignment. That's not a like big thing.
Okay.
So maybe so next week we'll start with the supply, but next week in the session I'll try to show you the realignment. Okay. With some example.
We are having some concept like attribute transformation and attribute as a key figure.
Yes. So that will see. Yes. So that will see the same attribute as a key figure and attribute transformation in supply. There it will, because at here in demand we are not changing anything at the key figure level, right? Whatever data in the sales history, we are just using it for our forecasting purpose. But in supply, you will be playing at the key figure level. Some like penalty costs will be putting, and some lot of other constraints will be putting. So there we'll be able to understand that attribute as a key figure.
Okay. And we are having some IBP operators as a advanced simulation and copy operators.
Yes. Yeah. So whatever. So this copy operators, I'll so whenever it is required, I'll explain you. I can give you that overview right away, but wherever that business like requirement is there, wherever we require it, then it will like help you to understand. For example, copy operator, it's kind of that demand release which we used to perform in our DP to SNP demand release in APU, right? So same thing we can do using copy operator. So there are other things operator also, copy and disaggregate operator. So based on the different like processes we'll be doing in different modules, then I'll show you that way the operators.
Yeah.
Okay. So in demand planning, generally we play at the web UI only. Excel UI we haven't used that much till now. Lot of settings we do in the supply.
Yeah, what's your point?
Okay. Yeah. So so just to repeat again, we'll be having next session on 24th, not 23rd. Okay.
So from like in IBP, there's no concept of functional spec, anything like that. You know, it just is all this is once implementation is done, there's no scope of.
Function. So in project, I'll not say there's no scope of function specification, because in your project you'll be having the integration with ECC and S4HANA, right? There you'll be your all BAPIs and bodies to transform your data. So there you have to prepare your not a function specification, but technical specification is main thing.
So once the project is implemented, like this implementation is done, there's no much scope of support. Looks like
support, yes. Not a long-term support. Like generally we call it as a hypercare. So maximum 2 months or 3 months of hypercare. Generally, client asks for 6 months hypercare, but we suggest, as our practice, we suggest 2 months hypercare. But it depends on them if they wanted to have a like longer hypercare support.
Okay, thank you.
I'll just stop the recording first.